In this video, we're going to take a look at section 3.2, which is on solving by substitution. So in the previous section, we saw how to solve systems of equations by the graphing method. This time, we're going to take a look at a different method called the substitution method. So our first objective is to solve systems of two equations by using the substitution method. Now, the strategy for this method is, first, you're going to solve for one of the variables for one of the equations. Then you're going to substitute the expression for that variable into the other equation. Now with step 3, you're only going to have one variable in that equation, and you're going to solve for that variable. Step 4, you're going to substitute the value of the variable into one of the equations and solve for the other variable. So that way you have your x and your y. So let's take a look at this first example. Solve the system of equations by the substitution method. So we have two equations, just like we saw in the previous section. Our first equation is x plus y equals 6, and then the second one is y equals x plus 2. So our first step is to solve for one of the variables for one of the equations. Now sometimes it's a little bit easier to solve for one variable over the other. And there's also a way that you could avoid fractions as well. Okay. So sometimes if you solve for one particular equation, you might not end up with fractions. It might be a little bit easier to substitute. Now, if you take a look at the two equations that are given to us, if you take a look at the second equation right over here, our y is already solved for. We already know that y is equal to x plus 2. So what we're going to go ahead and do is we're going to substitute this x plus 2 for our y in the other equation. So we end up with x plus, and now my y, I'm going to change it into x plus 2, and I have equal to 6. So now notice with the equation that we have, all we have is an x. Okay, we don't have any more y's in this equation. So what we're going to go ahead and do is solve for x. So we have x plus 2. This is going to give us 2x plus 2, and we have equal to 6. Now continue to solve for x. Go ahead and subtract 2 from both sides. You get 2x is equal to 4. And now we could go ahead and divide both sides by 2, and we get x is equal to 2. Okay. So now we solved for one of the variables. We know that x has to be equal to 2. So now we're going to substitute this value into any of the equations that we have. Any of the first two equations that we have, and then we can solve for y. Now, once again, it might be a little bit easier to choose one over the other. So if we take a look at that second equation, our y is already solved for. We already know that y is equal to x plus 2. So if I just plug in my value that I found for x into that second equation, I'll figure out what y is pretty quickly. Okay, so we're going to plug in. We're going to plug this into y equals x plus 2. So we have y is equal to 2 plus 2, which gives us y is equal to 4. And now we have the solution to our system. So let's go ahead and write this as an ordered pair. We have 2, 4. Let's take a look at another example. Okay, so we're going to solve the system of equations by the substitution method again. So let's take a look at our two equations. If we take a look at that first equation, we notice that y is already solved for. Okay, so let's go ahead and plug this into our other equation. So let's plug in 7 minus x for our y in the second equation. So we have 2x minus, and now we're going to change y into 7 minus x. And we have equal to 8. Okay, so now notice in our equation, all we have is an x. So let's go ahead and distribute out this minus sign, and let's solve for x. So we have 2x minus 7 plus x is equal to 8. Let's go ahead and combine like terms. So we get 3x minus 7 is equal to 8. Add 7 to both sides, we get 3x is equal to 15. And now let's divide by 3. So we get x is equal to 5. So now we know what our x value is. So let's go ahead and take our x value and let's plug it into that first equation, the y equals 7 minus x. You could plug it into the second equation as well. You could plug it into the second equation, but then there's a little bit more work to solve for y. So it's a little bit easier if we just plug it into that first equation. So we have y is equal to, we have 7 minus, let's plug in our x, which is 5. So we get y is equal to, so 7 minus 5 gives us 2. And now we have our x and we have our y. Let's take a look at another problem. Okay, so same type of problem, solve the system by the substitution method. Now we're given these two equations. And now in this problem, we don't have a variable already solved for. Okay, so what we're going to have to do is choose one of the equations and we're going to have to choose a variable to solve for. Now if you take a look at the second equation, if you take a look at this equation, notice if you were to solve for x or if you were to solve for y, you'd end up with fractions in your equation. So for example, if you solved for x in that second equation, you'd have to subtract 7y from both sides, and then you have to divide by 5. Okay. So on the right hand side, you're going to end up with two fractions. Let's go ahead and take our first equation, 4x minus 2y equals 16. And now let's solve for one of these variables. Okay. Let's go ahead and solve for our y. If you choose to solve for your x, that's completely fine. You'll still get the same answer. Okay. So let's go ahead. I'm going to solve for y. So I'm going to subtract 4x from both sides. You get negative 2y is equal to negative 4x plus 16. Now let's go ahead and divide both sides by negative 2. We get y is equal to, so negative 4x divided by negative 2 gives us positive 2x. 16 divided by negative 2 gives us negative 8. Now we have y solved for. Now we have to plug this expression in to the other equation. Okay. So the equation that we used was the first one and we solved for y. Now we're going to plug in this expression into our second equation. Okay. So we're going to go ahead and take this and plug it into our second equation. So we have 5x plus 7 times, and now we're going to change y into 2x minus 8, and we have equal to 1. Okay, so now our remaining equation, all we have is one variable, we just have x. So let's go ahead and solve for that variable. So you have 5x plus 14x minus 56 is equal to 1. Let's go ahead and combine like terms. So 5x and 14x gives us 19x. We have minus 56 is equal to 1. Add 56 to both sides. We get 19x is equal to 57. Now let's go up top here. Okay, so we have 19x is equal to 57. Now let's go ahead and divide both sides by 19. So we get x is equal to, so now the 57 divided by 19, this gives us 3. Okay. So we solved for x, now we still have to figure out what y is equal to. Now you could plug this into any of the equations that we have and then solve for y. You could plug it into this first equation, you could plug it into the second equation, you could even plug it into the modified version right over here. You could plug it into the modified version of equation 1 where we already had y by itself. So let's go ahead and do that because it would be a little bit easier. Plug into y equals 2x minus 8, and now we'll be able to figure out what our y value is. So we have y is equal to, we have 2 times 3, then minus 8. So we have y is equal to 6 minus 8, which gives us negative 2. So now our ordered pair, we have 3 comma negative 2. So with all these examples that we've seen so far, we have one solution. But just remember, in that previous section, we didn't always end up with one solution. Sometimes we ended up with no solution, and other times we ended up with infinitely many solutions. So with these particular examples, if you were to graph them, like the previous section, they'd only intersect at one spot. Let's take a look at this next one. So first equation, we have y plus 2x is equal to 3. And then the second equation, we have y plus 2x is equal to negative 4. Okay, so we're going to solve for one of our variables in one of the equations. Let's just go ahead and take that first equation. And then the more convenient variable to solve for would probably be y, because all we have to do is subtract 2x from both sides. So we have y is equal to, we have negative 2x plus 3. And now we're going to go ahead and plug this in to the other equation. So we're going to plug this into our second equation. Okay. So we have negative 2x plus 3. So I'm changing my y into negative 2x plus 3. And we have plus 2x is equal to negative 4. Okay. Now let's go ahead and combine like terms. So the negative 2x plus 2x, these cancel out with each other. So all we're left with here is 3 is equal to negative 4. So we were trying to solve for x, because that was the only variable remaining in this equation, but they ended up canceling out. And we're left with this statement that is not true. 3 is not equal to negative 4. Okay. So in this particular case, if your variable completely cancels out and you're left with the statement that's not true, this is no solution. There is not an ordered pair that would make this system true. That would make both equations a true statement. And the reason for that is because these are parallel lines. These two lines, they never intersect each other, which means that there is no solution for that system. Let's go ahead and take a look at one more problem. So solve the system by a substitution method. Okay, so let's choose one of these equations and solve for a specific variable. If I take a look at that first equation that's given to me, it'd be a little bit easier to solve for x, because all I have to do here is just add 3y to both sides, and I get my x by itself. So I get x is equal to, I have 3y plus 1. So now we have to go ahead and take this expression and plug it into our second equation. So we have 6y minus 2 times, and we're going to change our x into 3y plus 1. And we have equal to negative 2. So now all we have left in this equation is y. So let's go ahead and try to solve for y. So let's go ahead and distribute this negative 2 out to both of these terms. We have 6y minus 6y is, so 6y minus 6y minus 2 is equal to negative 2. And now once again, our variable is going to cancel out. So the 6y minus 6y cancels out, it becomes 0. So we're left with negative 2 is equal to negative 2. So something similar happened in this problem as the previous one. The variable that we were trying to solve for completely canceled out. But now in this case, we're left with the statement that's true. Okay. So in the process, if both of your if your variable cancels out completely, and you don't have a variable to solve for, and you're left with the statement that's true, that means you have infinitely many solutions. So we saw this case in the previous section as well. The reason why we have infinitely many solutions is because these two lines are the same. They intersect each other at every point. So that was it for 3.2. Remember, if you have any questions, do not hesitate. Just email me and I'll help you out.